Mean, median, mode, range, those are terms that you have probably used before and you know the basics, and I just want to cover a few things. I'm going to give an extra few little nuggets, just kind of like with the lines in the last one, so still see this one through. You may or may not need to take notes. You might be fine to just watch, and all these skills are going to be addressed again. The key to understand is that mean, median, mode fall under a category called average. And here's a fun little fact. If you're ever watching an infomercial or reading an article and it says average, if they don't explicitly say which one they're using, it is equally accessible for them to use any of those three. So unless they say the mean, median, or mode is being used, or you see the formula, if you hear average, you really don't know what they're saying. And range is a way that we can describe the spread. To clarify, average is any single number used to summarize a set of data. So you've got a whole bunch of values and you're trying to come up with a single number to represent that information. That is what is meant by an average. Spread is how close or far apart the data is. There could be instances where the average is the same, but there is a difference in the data in that the individual data points might be very close together or might be very far apart. For example, suppose you had a soda can filling machine and one of your assembly lines put 12 ounces in every single bottle, and another assembly line either put 0 ounces in a bottle or 24 ounces in a bottle. Pretty quickly, you can probably understand that the mean or average of either of these is going to be 12 or the same, but these are not the same scenario. How you would approach adjusting this machine that's consistent and just hitting the wrong target is very different than how you would approach fixing this machine, who obviously is inconsistent in its results. There may be other circumstances where you're kind of playing off the balance of having a high reward, high risk scenario, and you want to play and gravitate towards this option. So it's just good to keep in mind that there's pros and cons to both, but we need to recognize that there is that difference. So this would be an example of having low spread, the data points are close together, and comparatively having a higher spread, the data points are further apart. To dive into our actual calculations of mean, median, mode, and range, we're going to take a look at a data set. I'm going to point out just a few highlights of their traits. So coming on down, I have these two lists of numbers. You'll notice they're pretty much the same, 3, 5, 8, 8, 13, or 130. And I want to do that because we're going to come down here and I'm going to go through just some details. First up, mean. When we think about mean, figured it's best to just explain these by way of example. When we calculate the mean, it essentially comes down to add up all of your data points and divide by how many points there are. So to calculate that mean, I need to do 3 plus 5 plus 8 plus 8 plus 13 over 5, because I have a total of 5 data points. I didn't get so far as to actually do this calculation, so 3 plus 5 plus 8 plus 8 plus 13 is going to be equal to 37 divided by 5, which, just because I don't want to say it wrong, is 7.4. If necessary, the convention in AP Stats, unless you are told otherwise, 2 decimal places, pretty much always. Part of that has to do with percentage, right? Percentage is 2 places. So general rule of thumb is unless the situation dictates otherwise, either because of the accuracy of our numbers or if you need something else, you are always going to go 2 decimal places. In this case, it stopped at 0.4, so I'm going to stop right there. I can calculate the mean over here with the same thing, 3 plus 5 plus 8 plus 8 plus 130. Divided by 5. I'm going to fix that on my data over here. That's 154 divided by 5. And this pen is apparently dying. I hope I can make it to the notes. Or 30.8. Okay. So in that case, we've now calculated both means. You add them all up, divide by how many there are, and you get your answer. So this first data set has a mean of 7.4. The second data set has a mean of 30.8. After mean, we have what is called the median. The median very simply means middle. If any of you are driving, you probably at some point in the handbook or in your DMV test heard about the middle of the roadway being called the median, where the concrete barrier is. So all that means is we need to find the middle number of our data set. So when I come and look at this data set right here, I'm going to cancel one below and one above, and I'm going to repeat that, canceling 2, which gives me a middle number of 8. And it would be the same over here if I canceled one above, one below, one above, one below, one above. I think I could get that right. One below, one above. Again, I have that middle number of 8, and it hasn't changed. Now, one extra little tidbit for median is you might be saying, hey, what if your data set was this? 3, 5, 8, 9, 11, 15. Because the issue here is if I cancel one above and below, a second above and below, I now have 2 numbers in the middle. So what do I do to find that median? Well, it turns out median still means middle. So what you're going to do is you are then going to find the mean of those 2 numbers, add them up, divide by 2, and in this case, you would, for that data set in red, report the median as 8.5. So if you have a pair of numbers in the middle, all you got to do is add them up, divide by 2, and that will be your median. So it is possible for the median to not actually be a specific data point in your data set. And then finally down here we come to mode, which the easiest way to think about mode is mode stands for most often, which basically just means which data point shows up the most often. So in this case, if I'm looking at both these data sets, this data set right here, 8 appears twice. So my mode is going to be the number 8. And it's going to be the same over here. 8 shows up the most often. Again, it would be 8. Now, if you had a data set that did not have a number that appears more than once, so I'm going to go for another what if, and I'm going to copy that same data set right there, 3, 5, 7, we're going to go 8, 9, 11, 15. You'll notice this data set does not have any numbers that repeat. So in this data set right here, my mode would just be does not exist. DNE or does not exist. Okay? On the flip side, consider for a second if your data set was this, 3, 3, 5, 8, 8. Well, 3 appears twice, 8 appears twice. So there isn't one that appears more often than the other, but there's clearly kind of 2 bumps in our data, if you will. So in this case, we would need to report both numbers as the mode. It is possible to have more than one mode in a data set. They do need to be equal. It's not like, oh, this one has 7 and this one has 6. They're close. It's like, no, if they're exactly the same, then we can report 2 modes. Looking at all of this, again, remember, all 3 of these are averages. So if someone was dealing with both of these data sets and they reported to you, hey, I found the average, they could tell you the mean, median, or mode and be accurate. What I want to highlight right here is median. Or sorry, not median, mean. Look at how different these numbers are. 7.4 and 30.8. Come down to median. We got the same number. Okay? One of the things you need to realize when we're looking at variable data is the mean is heavily affected by what is going to be called an outlier. This 130 is way bigger than this 13. This 13 is closer to the rest of the numbers, whereas this 130 is very different from all of the other numbers. And so what that means is there are certain contexts where one measure might be more appropriate than another. So for example, if we were keeping track of heights of Escalon High School students, heights of students in a classroom are all probably pretty close together, in which case our best case for mean, or the average, is probably going to be the mean. In comparison, if we were doing salaries in the Bay Area and you had a bunch of workers at McDonald's, workers at the grocery store, workers at the gas station, oh look, there's Jeff Bezos. Oh look, there's Zuckerberg. Oh look, there's Bill Gates. Like, you start throwing a couple of those outliers in there, they're going to heavily skew the data. If you have really far numbers away from your data, we jump down to the median as our default. We're going to unpack exactly when we use each a little bit more, but that's just a little reference there. To finish this up really quickly, because I've only got a little bit of time, I don't want to make this too long. The last thing I need to address is range, and range is really straightforward. Range is simply your maximum value minus your minimum value, okay? So my maximum value in this set is going to be 13. I'm going to subtract my minimum, which is 3, and so my range would be reported as 10. Notice the range is a single number. The most common mistake you'll see on the AP exam is when students are reporting their range, they'll say the data goes from 3 to 13. No, if you're describing the data another way, that's a valid statement, but if you were specifically answering the question of range, it is reported as a single number.